What if you could get 33% more out of your AI infrastructure without buying a single new GPU? No hardware upgrades, no new data centers, no bigger budget. Same cluster, same workloads, same chips. Just a different order of operations. A team at Dharma-AI just published exactly that result, and the implications for enterprise AI are massive. Stick around, because this is the kind of efficiency unlock that quietly reshapes how the whole industry thinks about GPU capacity. Everyone in enterprise AI is obsessed with getting smarter models. Bigger parameters, better benchmarks, faster inference. But Dharma-AI's latest research argues the real bottleneck forming right now isn't intelligence. It's utilization, specifically GPU utilization. You've got racks of incredibly expensive hardware sitting in data centers right now, and a meaningful chunk of those GPUs are idle, reserved, or blocked. Not because demand is low, but because of how scheduling decisions get made. Here's where it gets precise, and precision matters. Keep the GPUs busy is not an instruction a system can act on. The real decision is far narrower. Which GPU runs which job, in which time step, at what priority. Formally, that's one binary choice per combination of GPU, job, and time step. The output is a grid. Every GPU across the full scheduling horizon with a job name in each cell or nothing at all. 4 workload types compete for that grid simultaneously. Training runs, real-time inference, batch inference, and quantization jobs. They split into 2 fundamentally different allocation shapes. Training, batch inference, and quantization are batch-like. Each job needs a contiguous block of GPUs held without interruption until it finishes. Real-time inference is the opposite. Elastic, driven by a demand curve that changes every time step, growing and shrinking as live traffic does. The comparison baseline throughout the Dharma-AI benchmark is a FIFO scheduler. First in, first out. Real-time inference gets served from a fixed reservation, and every other job is placed in arrival order without any regard for priority. Under light load, that's fine. When the cluster has slack, FIFO and anything more sophisticated fill the same fraction of the pool. Contention is where the ordering cost stops being invisible and starts costing real capacity in 2 ways. First, the reservation problem. Real-time inference cannot wait for capacity. GPUs must be ready the instant traffic spikes. A FIFO scheduler has no mechanism to release GPUs during a demand trough and reclaim them before the next peak. So the only safe move is to reserve each application's maximum daily demand for the entire day. An application needing 6 GPUs at midday and 2 at 4 a.m. holds all 6 for 24 hours. The second way FIFO costs you is subtler and arguably more expensive. Under real contention, which jobs fit at all depends on the order you place them, not just on how much total capacity exists. Order is not a tiebreaker applied after the capacity question is settled. Order is the capacity decision. FIFO places each job as it arrives, without weighing what that job is worth, and without checking what else still needs to fit inside the scheduling horizon. So high priority work waits behind whatever asked first, and capacity gets committed to placements that later, more valuable jobs simply cannot use. The Dharma-AI team describe it as the GPU equivalent of an airline assigning aircraft to whichever charter called first, then finding nothing left to fly the route that actually pays. So what does the constraint-aware allocator actually deliver when you run the numbers? Across 5 benchmark scenarios built specifically for genuine contention, The Dharma-AI allocator improved both axes simultaneously, utilization and value, with no trade-off between them. Utilization moved from a band of 52 to 85% under FIFO, up to 72 to 88% under the allocator on the same 8 GPU cluster. Priority-weighted value rose between 24.6% and 105.1% across those scenarios, averaging 52% improvement. Every scenario, both metrics, no exceptions. The single strongest case was a training-heavy workload on 8 GPUs. Utilization went from 53.6% to 87.0%, and priority-weighted value more than doubled, up 105%. Take a moment to let the economics land. Enterprise GPU clusters are not cheap. The hardware depreciates whether it's running or sitting idle, and every percentage point of utilization you're leaving on the table is money dissolving in real time. Dharma-AI's framing is that utilization is where the next real constraint in enterprise AI is forming. And their benchmark suggests the gap between a naive scheduler and a constraint-aware one is not marginal. It's 33 points. It's doubled output on your most valuable workloads. And none of this requires new procurement. If this benchmark holds up across broader production environments, the conversation around enterprise AI infrastructure is about to get a lot more interesting. If you found this useful, hit like and subscribe. We cover the infrastructure and research stories that actually move the needle in enterprise AI. Drop a comment below. Is your team dealing with GPU utilization problems? And are you using anything smarter than FIFO? I read every single one.